Good afternoon. I hope everyone had a great lunch. My name is Huyen. I'm an Android developer, have been for somewhere between 6 and 7 years, and I'm currently on the Android team at Trello. And I love custom views. Like, I think in the modern parlance, I am a custom view fangirl. They're one of my favorite parts of Android. And you know, it's kind of weird though, right? Because the platform comes with all of these really great widgets and views, like button and text view and view pager and layouts and linear layouts and straight layout now. And why would you ever want to write your own custom view? Well, there are a couple of good reasons why. So, say you are building an application and a component just doesn't work quite the way you want. You know, I remember like on a previous gig I was on, we were using some text views or edit text, and the input type that we wanted to use just wasn't in the current, was in one of the later SDKs, and we wanted to backport it. So sometimes, you know, there's stuff like that. Or maybe you're trying to do a new and innovative and really cool interaction or animation or kind of like just, you know, UI. And you just can't make it work with the current Android components. Maybe you need a custom view. Or maybe you just want to make your code a little more reusable. Maybe you have like some logic that is really cool and you want to use in different parts of your application and you don't want to copy paste XML everywhere. Or maybe you just want to make it more modular. Maybe you have a UI that's really complex and it's got a whole bunch of things going on, and you want to have good software engineering, good software design, and kind of separate things out. Custom views can help you with that as well. And what about performance? Say you have a really complex UI, it's beautiful, but it doesn't run well. And a lot of that has to do with complexity. If you have really nested views, if you have just a lot of views, period, that can drag your performance down. So custom views can help you with that as well. Now, the fangirl will tell you that there are some reasons why you shouldn't do custom views. They are time-consuming. They are difficult. And really what's happening is, like, the great thing about using platform widgets and views is that you have so much in them. You have so many features. You've got accessibility. You've got like different interactions. You've got animations and styling and all that wonderful things that Android provides us. If you do a custom view, you have to do a lot of that on your own. And so that's a disadvantage. And custom views won't always be the solution for you. But I'm willing to bet money that if you do Android long enough, you will do a custom view at some point. Please don't take me up on that bet. But I'm pretty sure that at some point you will need to do a custom view. And so the point of my talk here today is that custom views are great, and that if you have a decent foundation, a decent understanding of how views work, about how views are drawn to the screen, and same thing with view groups, you'll be able to do a lot. And it's not just that view groups or custom views and view groups are a means to an end, or a means of doing cool UI or making your UI more performant. It's a great way of just understanding how views and layouts are drawn. And kind of the more you understand this process, kind of like the better code, the better applications, the better you can debug, you kind of just get that extra knowledge to kind of like amp up your Android development. So for this talk, there's a lot of different facets to doing custom views. And there's a lot of ways to add like different kinds of like attributes and animations and gestures and touches and all kind of cool, sexy stuff that you could probably do an individual talk on for each one. I'm not going to focus too much on any of that right now. The goal of this talk is that hopefully when you leave here, you have a basic understanding of how custom views and view groups can be done, and a good starting off point to kind of doing all the rest of the sexy stuff after you get your kind of custom view kind of bones in order. So today, I'm going to start off by talking, how does Android draw views? How do your view hierarchy or your view layouts get to the screen? I'm going to talk about how do you go custom. There are a lot of different ways to do custom views, a lot of different kind of strategies. We're kind of going to go over, like, we're going to have an overview of some of them, but we're just going to focus on a couple of them. Next, as the title of my talk might suggest, we're going to talk about something called measure, something called layout, and something called draw. But we're going to talk about them in a little bit of a different order. We're going to talk about what does it mean when views are drawn, and how do we draw custom views. And then we're going to step back and talk about how we measure our views. And then we're going to take another step back and talk about view groups. Now, once you kind of get draw and measure down, that's like kind of like the base things that you need for a custom view. Now, view groups are also views, but they're a little bit different. So we're going to take a step back and see how they are different from doing custom views. And then we're finally going to talk about layout and what do you do when you're laying out a custom view group. All right. So how does Android draw views? So you're going to start off with your XML layouts. And those XML layouts have to be instantiated. They're going to be inflated, and each one of those views that you specify in that XML layout is going to be allocated and come to life. And eventually you'll have your view hierarchy with your views nested in other views and parents and children, all that good stuff. So once that view hierarchy comes into existence, 3 things have to happen before that view hierarchy ends up on the screen. And they are measure, layout, and draw. So each of these is a traversal of that view hierarchy. And each of them is a depth-first traversal from parent to children, to children's children, to children, all the way down. And what happens first is measure. And, sorry, back up. So basically there's 3 phases to how Android draws views. And you, as a developer, have kind of 3 entry points into this process. So for the measure phase, there's on measure. For the layout, there's on layout. And for the draw, there's on draw. So what happens with measure is that starting at the root, and then again going down from parents to children, is that the parent will figure out some constraints for each of its children on how big they can be. And then that child will take those constraints and then figure out, okay, given what the parent has told me about how big I can be, here's how big I want to be. And then basically it kind of like keeps that to itself until the parent's ready later on to kind of read that information. And in the process of calculating its own width and height, that child might actually measure any children that it has as well. So again, it's kind of a recursive process. Okay, so after measure comes layout. And layout is basically when a parent positions a child. So it'll assign it a final position and size on the screen. And finally, draw. So once everything is nicely measured and nicely positioned, they will actually start drawing. And drawing starts with the parent draws itself, and then basically requests each of its children to do the same. And something interesting to note is that basically whoever draws first kind of ends up kind of lower on the screen. So a parent will draw itself, and then when its children draw, those children will draw on top of the parent. All right, so now that we know the 3 different phases of how Android draws views, how can we take that and translate that to custom views? So there's a few different ways of approaching both custom views and custom view groups. Lucas Rocha did a really great article called Custom Layouts on Android where he explored kind of these different methods and he gave them different names. I added one. It's not quite as good as name as Lucas's, but so there's basically 2 general ways of creating custom views. You can extend an existing class, or you can extend the base view class, or extend the base view group class. So the easiest is at the top. And the easiest thing you can do is extending an existing view class. So I kind of mentioned my example from before where I was taking text view and extending it and just tweaking something that I didn't like. Arguably, it's kind of the easiest way to kind of get some custom logic or custom behavior out of a view. Or if you're getting really adventurous, you can do what Lucas calls a flat custom view. So instead of extending kind of a higher level widget, you extend the base view class. And usually you will do this when you really want to do totally custom drawing logic. If you have some really cool behavior that you want to do all on your own, that's when you use flat custom groups. Flat custom groups are also really good for performance. So basically if you have a layout that's got a lot of stuff in it, you can, rather than using a bunch of different views to implement that UI or that behavior, you can use a single view to do the same thing. And by that, you kind of reduce the number of levels in your view tree, and you kind of reduce the number of views that you're using. Okay, so on the view group side, Lucas talks about a couple different strategies. So when you're talking about view groups, so Lucas talks about this concept called composite view groups. So basically, it's this idea that where, say that I have a set of components, a set of buttons and widgets and whatever, and I just want to do something with them. Maybe I just want to separate them out to make my UI a little more modular. Maybe I just have some specific code or business logic that I want to apply to these, maybe I have a set of controls or something. So you can do what's called a composite view group. So you take your set of widgets and views or whatever, and you place them inside a platform layout, like a linear layout or a relative layout, and that is your custom view group. That is like where you kind of focus your logic on. Or if you're feeling adventurous, you can do what Lucas calls a custom composite view group. And rather than taking your set of views and sticking them in a platform view group, you're going to create your own view group. And this is really great if you want to do your own custom like layout logic. Like say you for some reason want to do a view group where you just lined out all the views like in a circle for some reason. You can use a custom composite view for that. And again, custom composite views can also be really good for performance. So you might have heard that relative layout sometimes is not so good for performance because it actually does measure layout twice. If you are running into problems with that and you want to kind of say, I don't want to do this, I don't want to handle this double layout pass, measure layout pass thing, what can I do? You can actually create a custom composite view group where you lay out everything very specifically and very efficiently and kind of help out your performance that way. So today in this talk, we're going to talk about the bottom. We're going to be really adventurous. We're going to talk about flat custom views and custom composite views. So back to measure, layout, and draw. So I mentioned that these are kind of like your entry points into the view traversals. So the secret is that you don't actually have to implement all three to do custom views and custom view groups. Depending on what you're doing and what you need, you only have to implement a subset of them. So let's start with custom views. I'm gonna do a simple custom view example for you. And I will tell you that if you're doing a flat custom view, the only thing you really need is on draw. You need to render that view on the screen, and that's all you need to do that on draw. You don't need layout because flat custom views won't have children, so it doesn't make sense. And you don't technically need on measure, but I will say that I think it's really, 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 really good idea that you do. And the reason you should do that is that while there is default measure logic in the base view class, it's not always the best case. And the thing is that if you want to create a cool custom view that's reusable that you can share with your teammates or the world, actually implementing on measure will make that view more reusable and just kind of render a little bit better in layouts. So what am I going to build for you today? I'm going to build one of these things, a tally counter. And that's what actually it's going to look like on the left or on the right. I know it's just so fabulous. This is exactly what I need what I need custom views for. This wonderful square with like numbers in it. And because I overthink things, probably because I'm an engineer, I actually have an interface for this. Not irrelevant to the conversation, but just if you see these methods later, that's what it is. So you can reset the counter, you can increment it, you can figure out what number it's on, and you can specifically set the count of the counter. All right, so when you're building custom views, the first thing you're going to need is constructors. You have to bring your custom view to life, and you're going to want to override the constructors in the base view class. So there's 4 of them, and you really only need to worry about the first 2. So these 2 constructors are used in 2 different situations. So the first one will take one parameter, a context. That context is the current context in which the view lives, and it's how that view will access resources, themes, etc. And you basically call this method, or call this constructor when you're building your view using the new operator. The second one is similar to the first one, but it has one extra parameter. It has that same context, but it also has an attribute set. So this constructor is used when your view is inflated from XML, and that attribute set contains all of those cool layout attribute sets, or attributes that you can specify in XML, like padding and text color and background, all that kind of stuff. All of those end up in the attribute set. And that's how your view can access those. So coincidentally, last week, my coworker, Dan, wrote a blog called A Deep Dive into Android View Constructors. So if you're kind of a little more interested in what's going on with view constructors, you can check that out. And you can probably check out his talk later. So here is my tally counter view, and here are the 2 constructors that I implemented for it. Now, when you're doing custom drawing, you're going to need a lot of stuff. You're going to need some objects. So what happens when you do drawing in a view is you're drawing on what is literally called a canvas. And you're going to be drawing with paint. Now, there's a paint object, and there's a text paint object. And these objects basically hold properties and styles that you can apply to your drawing operations. So things like stroke width and fill color and fill mode and all that good stuff, those all live in paint. So we're going to need a couple paint objects to do our drawing. And so here in my constructor, I'm instantiating them, I'm setting some fill color, And then I have my number paint. So my number paint is a text paint object, which I'm going to use to draw my sexy little counter numbers. And apart from setting a fill color, I'm also going to set text size. So something to remember when you're drawing in your custom views is that everything is relative to pixels. So any drawing operation you do is in pixels. But it's still really important when you're doing custom views to think in terms of DPs and SPs, just for flexibility and adaptability of your layouts. So something that you should get used to doing when you're doing custom view drawing is translating from DPs and SPs to pixels. And you do that by taking your value in SPs. So here I want my text to be 64 SPs. So I'm going to take 64 and multiply it by the scaled density of the display. So I'm going to access that through the resources, get the display metrics, and I'm going to get out that scale density, which is just kind of like the ratio that I need to multiply my 64 SPs by to get it to the actual pixel size it needs to be on the screen. And that's it. Another thing that you should be doing in your constructor is allocating any other objects that you need for drawing. So I mentioned paint. A lot of the drawing operations that you will do take geometric objects, so point and rectangle and things like that. All of that you should probably do in your constructor, which I did here. And then finally, any other kind of properties you need. So I'm actually going to draw like a rounded rectangle, so I have a corner radius. And again, working with pixels but thinking in DPs, if I want my corner radius to be 2 DPs, again, I'm going to pull out the display metrics, get the density value, and multiply that by my value in DPs. Cool. And then I actually kind of call my set count on my counter to kind of get it all initialized and ready for clicking. All right, so here's the meat of it, the on-draw. So just to run through the code real quick. So what am I drawing? I'm drawing some white text on a pinkish background with a line under it, and the text is centered in the canvas. All right, so how do I do that? So first thing, for convenience, I'm pulling out the canvas width and canvas height. And again, that canvas that gets passed to you in on-draw is what you're going to actually do your drawing operations on. Now, to get the center of my text, I'm going to calculate the center of my canvas. And then to start, I'm going to draw the background. So I'm going to call draw round rect, which is a method you can call on that canvas object. I'm going to calculate the bounds of my rectangle, which is basically the bounds of that canvas. And I'm going to pass into draw round rect this rectangle that defines the bounds, my corner radiuses, and that paint that I instantiated earlier, and that should draw my background. And then similarly, for the line I'm drawing, using the draw line method, passing in a coordinate that I calculated along with that line paint. And then finally, drawing the text. Drawing the text is a little bit more interesting. So the way I'm drawing my text here is that in order for me to center that text in my canvas, I kind of have to know how wide that text has to be. So I'm actually taking advantage of the text paint measure text method, which will take a string, and then based on the properties of that text paint, will let you know how many pixels wide that text is going to be. So I'm using that, and then I can calculate like where I need to position my text to get it centered, and then finally I draw a text, and that's it. That's all I needed to do to draw this absolutely gorgeous tally counter on the screen. And that's it. That's how you draw a view and get it to appear on the screen. Now, I have a click button up here, and that click button should increment my counter, but it doesn't. And I had a toast here just to prove to you that I'm actually clicking on the button. So did I not hook up something? No, actually, I did hook up something. So whenever that button is clicked, I'm calling set count on my counter. So what's wrong? Well, when I set the counter, I'm basically changing the state. You know, that counter is incremented, so the state's changed. But when I changed the state, I didn't actually draw the counter again to reflect that state. And that's something that you have to really remember when you're doing custom views. Anytime the state of that object, that state of that view changes, you have to be able to reflect that in the drawing. So how do you do that? It's pretty simple. You're going to use the invalidate method, and that invalidate method basically says to Android, hey, this view's dirty. Oh, that's the word that Android uses, but it's basically that drawing is no longer valid. It no longer correctly reflects the state of that view. And it will basically let Android know that, hey, this needs to be drawn. Android will draw it again at some point in the future. It won't happen immediately, but very, very soon. Something else that's kind of interesting is that when you mark a view as dirty, as it needing to be redrawn, any views that intersect that view on the screen will also get redrawn as well. So it's great. This is how you kind of ask for your views to be redrawn. Something that's really interesting to kind of look at is a different kind of an alternate invalidate method, which takes 4 integer values, left, right, top, bottom, And those allow you to specify a specific region that's dirty. So if you're looking at my counter, really anything that only ever changes is that text in the middle, right? So if I wanted to be a little more precise, I could just figure out like, a bounding box for that text and then pass that to invalidate. So again, being a little bit more precise. So in order to get my counter to actually be a counter, all I had to do was add this invalidate call to my setCount method. And once I do that, and click my button, yay, it's counting. So again, it's just these small little things, changing state, updating drawing, that will get your views actually doing things on the screen. So there's actually something interesting about this layout, which I'll talk about in a minute. But just to kind of finish off on drawing, here's some things that to remember, that stuff that I did wrong that I would love to kind of share with you so you don't do wrong. Don't allocate objects in onDraw ever, ever, ever. The reason for this is that onDraw will get called a lot. It gets called every time your view needs to be drawn. And if you're allocating objects in that, you can just imagine how much memory you're going to use if you just keep allocating objects in onDraw, so don't do it. And Lint will actually yell at you if you start allocating objects in your onDraw method. Invalidate only when you need, and invalidate only what you need. Again, drawing in the invalidation process is expensive. Don't do it willy-nilly, only do it when you need it. And again, try to be precise with it. If you can save some other views being drawn by using that invalidate with the 4 coordinates, and so that it doesn't intersect other views and the other views can just kind of chill on their own and be cool, then you can save yourself processing time and draw time. Something that always got me is that text is actually positioned at the baseline. So the baseline of text is where that text sits. But there's pieces of text sometimes that kind of go under that line. So if you draw a W, right? The W sits on the baseline, but then the little stem sticks out. So something that always got me when I first did drawing was that all my text always seemed to be higher than it meant to be. And that's because when you position text, if you position text at 0, 0, it's not like the bottom of the text that's at 0, 0, it's that baseline. So something to remember. And again, just to repeat myself, you draw in pixels, but think in DPs and SPs, again, to make sure that your custom views are nice and adaptable to different layouts and sizes. Okay, so I said there was a little secret in this layout. And the secret is that there's a button below my counter. And you can't see it. And you might say, well, when you probably made that view match parent. I didn't. This view is actually wrap content. Now, that's not bad in and of itself, but if you look at it, the counter doesn't need to be that high. And the thing is that the counter, because it doesn't implement on measure, it doesn't know how big it really should be. So this is why I tend to like to implement on measure, so that in cases like this, you can really do a lot more with that view. Like if I stuck this, sticking this view in this layout means that that poor button is all lost in the land of nowhere. So it's always good to kind of implement on measure so that you can make your views a little bit more flexible, a little bit more layoutable. That's a word I just made up, layoutable. So before we get to that, how are measurements made? So when a view is measured, it's actually kind of like a negotiation between that view and its parent. And the child and the parent kind of communicate to each other what they want in different ways. So the child communicates with the parent view through layout params. So layout parameters, basically how wide, how high does it want to be? And we use layout parameters all the time by calling layout width and layout height in your XML. Sometimes if you're really cute, you can do it in Java code as well. But that's basically how the child tells the parent how it wants to be laid out. And so whether your layout is being inflated from XML or whether you're doing everything by hand in Java, at some point you're going to call set layout params on that child. And at some point later, that parent is going to call get layout params to retrieve those layout parameters. All right, so at some time later, in the parents on measure, that parent will kind of look at that child's layout parameters and calculate how big that child should be. So there's a lot of factors that go into this, right? So if there's other children, how you want things laid out, that parent needs to figure out how big each child gets to be based on the available space and also on the layout parameters that that child requested. So in the parents on measure, it's going to figure all this out. And it encodes these constraints, basically how big each view can be through measure spec values. So measure spec value is an integer, and it encodes 2 things, a mode and a size. And the combination of these 2 can tell a child, you can be at most 300 DPs, or you can be exactly 500 DPs, or you know what, your constraint, your size is unspecified. You can be as big as you want. And these measure specs are calculated by the parent, one for width and one for height, and they get passed when the parent calls measure on that child. And when the child's on measure executes, it gets those two measure specs. And then it's up to the child to look at these constraints, look at these measure specs, and then look at its content and figure out how big it wants to be, or it can be, but still kind of conforming to those parent constraints. And then once it's figured that out, it's going to call set measured dimension, which is basically storing that measured width and height, that kind of desired width and height in that view. Now, something really, really important to note is that set measured dimension is mandatory when you're implementing on measure. If you don't call it, at some point you're going to get a runtime exception, and you'll be sad. I know I have been as well. And then at some point later, once that child has figured out its measured width and height, that parent will start laying out children. And the final kind of phase in measuring that child is setting a final size and position. And the parent does that when it calls layout on the child. So a child, in a way, has like two sets of dimensions. It has its measured dimension, and so it's measured height, or it's measured width and measured height, and you call get measured width and get measured height to get those values. And its final kind of width and height on the screen, and you call get width and get height on the child to get those values. So what does this actually look like in code? So I'm actually just going to focus for now on what the child needs to do when it gets those constraints from the parent. So my counter view. So let's think about this to kind of high level at first. So what I really want is for the counter to be just big enough to fit that text. So I'm going to be measuring text. And another thing that I want is I want it to have padding, right? I want to be able to use those padding attributes and have it actually kind of add a little more space to the top left and right of that view. So to start with, I'm going to measure the text. And so something that if you're working with text and drawing text a lot, you're going to get really friendly with is the font metrics. The font metrics is an object that lives in a lot of different places, but each text paint object will be able to give you a font metrics object. And that font metrics has all kind of properties related to the text. So there's things like ascent, descent, top, bottom. These are all kind of just notions about how high the text may be like above the baseline and how low it might be below the baseline. So I'm going to measure the text. Now, when you're working with on measure and you're trying to calculate the content or the size of your content, it's really good to think about edge cases of upper bounds. So in this case, rather than just measuring the text that I have right now, I'm going to measure the maximum text that I could render, like the maximum value I can render. So I think I set it somewhere to be like 9,999. And I created a string out of that. So rather than measuring again, like kind of like the count as it is now, I'm going to measure that just to make sure that I always am fitting like the biggest value. So my counter doesn't kind of like do this kind of accordion thing. So I'm going to measure that. Get a text width out of it, again, like before, using that measure text method on the text paint. And I'm not going to measure the height. Measuring text height in Android is a little funky, and that's just understating it. Sometimes it just doesn't work. So a lot of times you have to use your best guess and estimates. So here, instead of measuring the text, I'm going to use some font metrics, some font properties. I'm going to use the top, which is basically the maximum distance above the baseline that any glyph in that font can be, and I'm going to use the bottom, which is like the opposite value. I'm going to combine those and say, all right, that's probably the biggest that text is ever going to be. Next, to those two values, I'm going to add some padding. So what I'm going to do is I'm going to take those two text measurements that I calculated. I'm going to add in the padding. So I'm just going to call get padding left, right, get padding top and bottom, and then add those into that measured text width and height. And then once I get that, I need to think for a minute, because the parent said that I can only be a certain width and certain height, but I want to be this width and height. How do we reconcile that? Well, there's actually a method in the View class itself called resolve size. And resolve size will take a content size, so how big a view wants to be, and it'll take a measure spec, how big that parent told the child it can be, and it will reconcile them. And so it does a lot of that work for you, trying to figure out, well, if I'm this size, no. So it takes all that work out of you, and it's something that you should definitely use if you're doing your on-measure implementation. I cheated. I actually re-implemented it just because the resolve size is actually a little bit complicated. So just for the purposes of this talk, I re-implemented it myself and called it reconcile size. So basically what it does, and this is basically what resolve size does, is it looks at that mode that the parent gave you, And if that mode was exactly, then the method says, all right, you're going to be exactly the size that the parent wants to be. If it was at most, then it kind of checks the size that the view wanted to be versus the size the parent says you can be, and take whatever is smaller. And if that mode was unspecified, then the method will say, all right, you can be whatever size that is that you want it to be, that content size. And that's it. I measured my view, so let's see how it looks now. All right, so this is my measured counter, and it looks way better. It actually is fitting the text a little bit nicely. It's not, hogging all the screen. And hey, there's a button that was underneath there that has appeared now. So I'm sure that button is actually really, really glad that we implemented on measure, and you will be as well. And again, because now the view has a better notion of how big it can be, I can probably use this in different places without it kind of taking over the whole layout. So that was custom views. Let's talk about custom view groups. So view groups are views as well, but when you're implementing a custom view group, it kind of works a little bit differently. And that's because the view group has children. Whereas the flat custom view could be selfish, it only had to worry about itself. A custom view group has to worry about its children. That's like the whole point of the view group, is kind of grouping and placement. So the methods that you have to implement to get your custom view group off the ground are a little bit different. You have to implement on measure, because you have to be able to call measure on each of your children. You have to implement layout, number one, because it's abstract, so you really have to implement it, and two, because you do have to call layout on each child to get it actually positioned on the screen. If you don't call layout on the child, they become like 0 width, 0 height, out in 0, 0 land, so they disappear. And finally, you do not have to implement on draw. In fact, by default, the default behavior in view group is not to draw. There's actually a flag called set will not draw, and it's true by default. So I'm not sure why you would ever really need to draw on top of view group, again, because the point of the view group is grouping and placement. Maybe you do, but if maybe you want to, and if you do, make sure that you set will not draw to false. All right, so I'm gonna switch gears. I know the tally counter was beautiful and sexy, but we're gonna switch gears. So I have a list with some items, and this list item structure is pretty familiar in Android, right? Got an image view, got some text, and got some more text. You could probably do this with a relative layout, but maybe you're having some performance problems, or maybe you just want to play around with custom views and view groups. And that's kind of like just as an aside, like when you take the dive into custom views and view groups and you're a little intimidated because there's a lot going on, it's really good to start with very straightforward structures, very straightforward layouts like this, right? And if you have a layout that has like static content, relatively static content, if you have a layout that you can describe the layout of very simply, right? So here I'd be like, okay, there's an image, there's some text to the left, there's some text below there. That's a very straightforward layout. And it's a good way to practice and kind of get into using and implementing on measure and on layout. So just a little bit of my experience, because that's how I got into, that was my gateway drug to custom views. So here's my custom list items. So I'm going to work backwards and show you how I got this to look like it does. So here's the XML layout for that. I have the image view, I have the text view, and another text view. And it looks just like you might do with a relative layout, except that the root tag is simple list item. And that is the name of my custom view group that extends custom view group. And again, this is a composite view group, so I actually have very specific views that I have in the layout that I'm kind of bringing into the class, and I'm going to do some funky stuff too. So the on measure of parents of view groups are a little bit different, a little more complicated. Again, because they have to worry about children along with themselves. And there's a couple different things that I want to talk to you about that you should probably look into when you're doing on measure for your view groups. This is not required, but it is really, really good to do. So layout parameters. So there's a view group layout params class, and it encodes a width and a height. And that is the default layout parameters that you use with a straight up view group. It's not, so think about a linear layout. A linear layout has width and height, but it also has some cool other things like weight and gravity that aren't covered by the view group layout params class. So if you're creating a custom view group because you want to do something really cool with layout, like you want to you do a really interesting algorithm to lay out your views, you will probably want to consider creating a custom layout params class so that you can encode like different modes and different kind of properties that your users can set. So it's actually not too bad. And what's interesting is that margins, like we use margins all the time, right, to get everything positioned nicely. Margins are not in the base layout params class. So if you use the base view group and just use it straight up, the margins won't work. But there is a margin layout params subclass inside a view group. And in order to use margins within your custom views, you have to start letting the view group know that this is the layout params that you're going to use when you're instantiating. And there's 4 methods that you implement to get either margin layout params or your own custom layout params to be used by your custom view group. So the first one is check layout params. It's a validation method. It checks whether a particular view group layout params instance is valid to use with that view group. So if I stuck, say, a relative layout, specific layout params in a linear layout, check layout params be like, nah, no. That's not what we use around here. So that's for validation. Now there's 3 methods that actually generate layout params. So the first is generate default layout params, and that's called when your view group gets a view that has no layout parameters on it, so it can actually have some default layout parameters. Now there's generate layout params that takes a view group layout params, very long names, view group layout params as a parameter. And basically this is used when a view gets bad layout parameters. So like that situation I said before where we pass some relative layout parameters into a linear layout. So this method will actually give you a chance to take that layout parameter, like that invalid layout parameter object, and pull out stuff that you can use. So you can pull out the width, and you can pull out the height, and you can pull out any other properties that you can use in your specific layout parameters object, and you create a new valid version using some of those properties from the bad one. And then finally, there's generate layout params that takes an attribute set. And so attribute set is our friend from XML inflation. And basically, it's generating a set of layout params based on attributes specified in XML. So if you want to have, like, if you want to use margin layout params in your custom view groups, or if you want to create your own kind of cool, super, like, spec'd out layout params, you need to implement these 4 methods. So before I actually dig into the on measure, there's a couple of methods that you should know about that live in view group. So implementing a parent's on measure can be kind of difficult, right? Because you have all these children, they want to be different sizes, they want to be laid out different ways, and you only have so much space and so much padding, and you need to kind of make sure that everybody's layout parameters is satisfied to the best of your ability while still respecting your own, that parent's own, like width measure spec and height measure spec. And that sounds really complicated, and it sounds like it's a lot of work, and it is, but there are methods that will do it for you inside a view group. So there's 2 methods that will take a width measure spec from the parent, take a height measure spec from the parent, and take a view, read its layout parameters, and then figure out based on that view group's own constraints, and take that into account, but still kind of give that child like those layout parameters to the best of its ability, and it's called measure child. There's measure children, which basically just takes measure child and calls it on all of the children in that view group, so that's pretty handy. But if you like margins, so the thing about these first 2 methods is that they don't take margins into account. And a lot of that has to do, again, with what I said, the fact that margins aren't really handled by default. So there's actually this method called measure child with margins. And what it does is that it's basically the same thing as measure child, but in that calculation of kind of like, and reconciling of what the parent can be versus what the children want to be, it will take the margins into account. It will pull out the margins from that child and add them into the calculations. And okay, so finally, there's another method which you might not need to use, but is handy in case you want to go crazy and do your own stuff, and that's get child measure spec. And so all that kind of complicated logic I mentioned about reconciling, like how big the parent can be versus how big the children want to be, all of that is actually inside of get child measure spec. It does the hard work of figuring out a measure spec to give those children based, again, on what the view group can be and what the children want to be. And that's, again, called within measure child and measure child with params. But if you want to end up kind of doing your own thing, you can definitely call on that method. All right, so back to my list item. So here is just really quickly my implementation of the layout params methods. I want to use margins on my simple list item, so this is basically what I have to do to get it. It's pretty simple, not too much code. Basically, being able to generate that margin layout params object in these 4 different situations, so not too bad. and then the meat of it, so on measure. So I have an icon, I have a title, and I have a subtitle. So I'm going to measure them. And I'm going to use measure child with margins so that I get those margins kind of wrapped in the calculation. And as you can see, it's really not too bad. So the first thing I'm going to do is because the icon, because my image view is sitting here and the title and the subtitle kind of sit to the side of it, that icon basically kind of has like, I guess, #1 priority in terms of like measurement. So I'm going to measure that icon first. And when you call measure child or you call measure child with margins, you actually pass in along with the view and the parent's measure specs, you pass in 2 other integer values. And one integer value is called width used, and the other one's called height used. And basically, so as you're measuring your children, you'll start taking up space, right? So that parent will have less and less space to kind of dole out. And the width used and height used is a way for you to track and provide that information to the measure child and measure child with margins method so that it can take those into account for you. So the icon goes first. It gets free reign at all the space, so it passes in 0, 0 for width used and height used, and it passes in the parent's width and height measure spec. And then once we measure that icon, we want to figure out how much width it actually used. So we're going to call the get measured width. So we're going to get that icon's desired width, and we're going to add to it the margins. So the measured width takes into account the content and the padding, and now I'm adding in the left and the right margin to kind of see how much space that icon actually needs within that layout. So including itself and like its margins, okay? And now, so I've got the icon. Now I got to measure the title. Now the title sits to the right of the icon. So it has a little bit less horizontal space. So I'm going to pass in the width used by the icon. But the title actually gets free reign of the height. So I'm going to pass in 0 for the height. And again, I'm going to call measure child with margins so I can take the margins of the title into account. And now I'm going to have, once that's done, the get measured width and get measured height of the title. And then finally the subtitle. Poor subtitle, it goes last. It kind of just gets whatever's left over. So I'm going to have to calculate the width used by the icon, the height used by the title, and then I feed those into the call for measure child with margins for the subtitle. And then after that's all done, I finally have the measured child, or the get measured width and height for the child, or for the subtitle. Okay, so the children know, or the children of this view group know how big they want to be. The parent still has to calculate that. The parent still view, the parent still has to figure out what its measured width and height is going to be. So basically, all these lines of code are just taking everything I did up top and adding it all together. So adding together the measured width of the icon and the measured width of the title, figuring out like, you know, whether the title is bigger than the subtitle, like, you know, what the width of that actually has to be, and putting all that stuff together into a width and height. And then finally, I'm going to call that resolve size, the actual resolve size on the platform, to take that measured width, all the added up width and height of the icons and the title and subtitle. I'm going to pass all that to resolve size. I'm going to pass in the parent's actual width and height measure spec. And then it'll spit those out, and I can pass that to set measured dimension. So now I know how big that parent wants to be. And you've seen this before, but this is the result. So in some lines of code, I basically get, you know, a nice looking simple list item. Yes, I could have done it way faster if I just used relative layout, but again, you know, it wasn't too bad. Like measuring and laying out children in a view group can be verbose, it can be long, it can be a lot of code, but it's pretty straightforward. You know, a lot of it is just being able to kind of, in code, articulate how things need to be laid out, and turning that into code, and turning that into reusable view groups that are performant and that, that can do cool things. All right, so hopefully I've kind of like taken you through the basics of getting started with custom views and custom view groups. There are some things that I didn't do. There's a lot of stuff that I didn't do. I didn't set attributes. Like you can set custom attributes on your views so that people who use your views can like set different properties on them and change color and size. Like I could have totally done that with my counter, right? I could have given like anyone who uses it the chance to change the text and the type and the background color. You can do that with attributes. You should totally do that. Something that you should really do with custom views is add accessibility. And that's something you really lose when you don't use platform components, is accessibility. So say like my counter, right? I probably got like the click of, like, so if I had TalkBack on and I clicked that button that was incrementing my counter, TalkBack would, let me know when I was like clicking on it. But what if I wanted to add like accessibility so that every time the counter incremented, I actually like had TalkBack announce like the actual value of that? That would be valuable, right? If someone needed accessibility and was using my counter, I would want to add that. So definitely, if you're doing custom views, think about accessibility. And we have, speaking at the conference, a veritable expert on accessibility speaking tomorrow, giving the keynote, Kelly Schuster. If you're interested in doing accessibility, she knows a lot. So definitely follow Kelly. Something else that's really cool to do with custom views is custom drawables and custom drawable states. Custom drawable states, I wish I had time to go through, but like one of my favoriteest things to do with custom views. Ryan Harder, who actually spoke earlier on annotation processing, did a really good post on doing custom drawables. Marcos Paulo Damasceno did a really great talk last year on doing custom drawables as well. So something else that if you're kind of interested in kind of doing really custom graphic work and custom drawables and making things that are really cool and reusable in different places, check those out. Something else that you can do from here is just explore all the different drawing operations there are. And there are a ton. You can do so much with canvases. Romain, who gave the keynote, I remember when I first started doing Android, I would just read his blog constantly. He knows a lot about how the canvases work and how the drawing, all those kind of like the drawing architecture works, obviously. So I still go back and read his own blog posts constantly as reference. Chuki, who's running the conference, did a really great presentation on using filters and shaders. So these are ways, basically different ways of adding different kind of like flavor and coloring to when you're drawing. It's really cool stuff. If you finish all that and you want to keep doing drawing stuff, but you also are worried about performance, you can start looking into hardware acceleration and basically things you can do to get things to draw more efficiently. And you learn about hardware layers and display lists. Eugenio Marletti is a really cool person if you want to follow for this. He knows a lot about custom views and display lists and kind of making things really efficient. He works on the team at Clue, and Clue is an app that basically does a whole ton of custom view work, and it's a really great app that if you're trying to get into like really heavy custom view work, is a great app to just look at and see the possibilities of custom views. And where to go from here? I highly encourage you to start playing with custom views if you haven't already. It'll teach you a lot about the Android platform and about how views work, about how layouts work, and it'll just kind of give you this opportunity to really do really cool and interesting things with the platform. I still do them. I probably do them in more situations than I need to, but I really encourage you to give it a shot because it is a really cool way to explore the possibilities with Android. And that's it. I have no idea whether I'm late or I'm early, but thank you so much for coming. And yeah, just find me on the internet if you have any questions. Thanks. Okay, so the question was at what point, sorry, just so to paraphrase for the camera. So the question was at what point do I want to consider, instead of doing custom views, doing fragments and mostly involved with like kind of like extra view kind of functionality, like sounded like you're talking like business logic and loaders and all that kind of stuff?
More like lifecycle events.
Lifecycle events? Oh man, I'm going to start off, so it's basically at what point do we switch off from using custom views to fragments, kind of based on when we need to kind of hook into lifecycle events. Ish? Sorry, okay, so I'm going to start off with like my favorite answer, which is also a sucky answer, was like it depends. But because it's true, and so it's a good question. It really depends, and I feel like, so it's actually really funny. When I was researching this talk, I was watching a talk by Romain and Adam Powell, and they mentioned a lot of times that back in the day people had requested lifecycle hooks into the custom views. And they said, well, you know, there's a bit of separation between views and the rest of the Android platform, like activities and fragments. So a lot of times you can handle hooking into the lifecycle through callbacks. So, you know, you kind of implement some kind of callback that maybe the activity or fragment can implement. So if it has, like, if you want to do something on start, so that the activity or fragment in its on start can kind of call back to the view so that it can do something. In terms of performance and like fragments, like that's like a religious war in Android. It kind of just really depends. I feel like custom views and performance, it kind of depends also a lot on your priorities. A lot of times, like, it just really depends. Like, I feel like custom views are very specific towards UI and interaction and building kind of like the front-facing side of things. And that, I mean, if you really have performance problems, like I feel like if you're really having a lot of communication between the view and the activity and a fragment, that the priority would be to make that communication, that part, that business logic as performant as possible. And then if you continue to have more like UI-related problems, to kind of start stepping in there. But a lot of times I feel like get like the business logic, get the actual like gears working on your application, and then kind of like if you continue to have UI problems, then kind of step to it that way. And I have 0 time left, I'm sorry. Thank you all so much for coming, and I'll be around, so if you want to ask me questions, I promise I won't say it depends every single time. So, thanks.